Right. So we shall start with this great topic, time value of money. That is a great topic. And on money. I have several questions maybe before we start. The first question is, if I owe you money today, which is the best time for you to ask me to pay you? If I owe you money today, which is the best time for you to say? Now, maybe people will think I owe you some money, be 10,000. Which is the best time for you to request for that money? Next, depend with the argument. Assume there was no agreement. Huh? Yeah? Payday.
Yes.
Oh, the payday or the civilian tariff. Okay, that's good. Kevin, what do you think?
In January, you want it to be with
He'll be okay. Depending with the situations and the month that we are in. All right, right. Your responses are very good. Wow, what can you say? Best time. Oh, now. I pay you now. All right. Good. You guys are great. Time value of money. And so class, just you can say that up. It is a concept. It's a concept. Which state or that state is a concept that states the value of a shilling today is worth more than the value of a shilling tomorrow. Is a concept that states the concept that states the value of a shilling today is worth more than shilling tomorrow. Value of a shilling today is worth more than a shilling tomorrow. So today represents today and the days past today. Tomorrow represents tomorrow and the future. So for those people who say now is the best time for me to pay that money. Because if I stay with this money until the time I get the salary of such, that money will have reduced the value. Because we don't want it to reduce the value, get that money now rather than. Now this topic will help us to know if somebody promises you money, maybe in future, you can say the future is 5 years, 10 years, or such. Also, the government is forward for this one. Give you 10,000 or 1 million in 2027, if so and so we. You see, there are those promises, right? What you do, you compute that money. How much will be the value of that money to pay? Tell that person to bring that money to pay. Instead of waiting for that future, because the money will have reduced. Assume I have 1,000. I go to supermarket today, I buy some product, you got that 1,000. Is it the same with the person who will take that 1,000 next year, go to the same supermarket? Will that person buy the same product like I? You find that this person will buy less product because the value of that 1,000 will have reduced, right? So don't wait for tomorrow If you need the money, have it now. Have it now. So we have two types of cash flow because we shall be dealing with the future cash flow and some present cash flow. So we have two types of cash flow. Down there, just split types of cash flow. We have two types of cash flow. You can remind us one. You can remind us one. This is the time that I just do your name correctly. Remind me, then recall. So the first type of cash flow regarding recall. Yeah, we can try. If you borrowed for financial reporting, we have regular cash flow. Regular cash flow. Thank you for trying. And irregular cash flow. So for the regular cash flow class, this is a uniform cash flow. Uniform. This is non-uniform and non-uniform. So if I start with this uniform cash flow, say IE or EG, whichever, on the regular cash flow, we have here 1, 2, 3, and 4, and each year the cash flow CF is 1,000. Each year the cash flow will be 1,000. That's just an illustration to show you how is the regular cash flow look like. For the irregular cash flow, have the year here 1, 2, 3, 4. So in this case, I have a cash flow of maybe 200, 400, 500, 700. See, the cash flow for year 1 is not the same as that of year 2, but remember, you can have 200 and the others are 400. That still is an irregular cash flow. Even if one is not, is only one cash flow which is not similar, you call that regular cash flow. Now, since we shall be dealing with this cash flow, it is always good to remember which cash flow you are dealing with. Are you dealing with the regular cash flow? Regular cash flow. That forms the base of answering any question. Which type of cash flow are you dealing with? Am I dealing with the regular or irregular cash flow? So that takes me to the concept of the techniques under these topics. The concept of time value of money, it falls under 2 techniques. Concept of time value of money. Concept of time value of money. Concept of time value of money for under 2 techniques. And the first technique is discounting technique. Discounting technique. And the second one is compounding technique. Started moving on well. Discounting technique and compounding technique. So I want us to define the two. We start with the discounting technique. Say that discounting technique, it is a technique. That help us to determine or to convert. It is a technique that helps us to convert the future value of cash flow into present. It is a technique that helps us to convert the future value of cash flow into present. You can say into present value, there's no problem. The future value of cash flow into present value. That is discounting technique. Compounding technique class is opposite of discounting. It is a technique or a method. It is a technique or a method that helps us to convert the present value of cash flow into future. 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 In that regard, we shall be guided, or we shall be getting the help from a factor that is known as BIFA and PB. We not write it that. So, for instance, if I measure into discounting technique, I measure into discounting technique, and I want to get the present value of a certain cash. I'll be assisted, or I'll be guided by the future value of that cash flow. And then I multiply by a certain factor. The factor may be PB or PBFA. The factor may be PB or PBFA. So this is R%, and yes, we shall elaborate on that. What we mean is that to determine, you can write this, to determine the present value of cash flow, determine the present value of cash flow, which are uniform. Determine the present value of cash flow, which are uniform. We use present value interest factor of annuity, usually PBFA, to determine the present value of cash flow, which are uniform. Decided to use the word uniform. We use the present value interest factor of annuity. We use the present value interest factor of annuity. Present value interest factor of annuity. This will help you to determine the present value of uniform cash flow or regular cash flow. At any given point you are dealing with regular cash flow, kindly note that we need to use this factor. This factor will help you to convert the future value into present. The future value into present. The future value into present. So the formula for PBFA is 1 minus 1 plus R raised to negative n divided by R. That is the formula for PBFA. BIFA. Because here, remember we say it's R% and years. R% and years. R% and years. Where R is the rate of return. R is the rate of R. The rate of return. R is the rate of return. N is the number of period. Number of period. Okay. And so if you want to determine the present value of a regular cash flow or a uniform cash flow, you're going to use this PBFA. This is the factor that we're going to use. So the general formula for that, the general formula for getting the present value will be given by future value multiplied by 1 minus 1 plus R raised to negative n divided by R, where this is golden to get, where PB is the present value, FB is the future value, and R, you know, it's the rate of return, and is the number of period. Number of period is our, and so this is the formula that you use when you want to get the present value of a certain cash flow. Very important formula there. Very important formula there. Very important formula there. Great. Determine illustration. determine the present value, value of the following cash flow. Determine the present value of the following cash flow. Use 10% as the interest rate. Use 10% of the interest rate. So the cash flow class are given below. So we have here 1, 2, 3. We have cash flow here of 70,000, 70,000, and 70,000 more. Wow. So you are required to determine the present value of the cash flow for the 3 years. The cash flow for the 3 years. 70,000, 70,000, 70,000. Let's determine the cash flow for the same. So the first thing, the procedure is to first determine the type of cash flow that we have. That is the first thing. The first step before even you start putting down the formula. So which type of cash flows are these? Regular, right? They are uniform. I can see a 170, a 270, a 370. Then I write down the formula. So I want to determine the present value. The formula is future value times 1 minus 1 plus half is negative n divided by that. Your step number 2. Step number 2. Step number 2. Step number 3 is now you start plugging in the figures. You start plugging in the figures as necessary. Start plugging in the figures. So we start plugging in the figure that we have. We want to get the present value, and the future value in this case is the 7, right? And the 1 figure 1 minus 1.1 leads to negative. Negative how much? For how many years? 3 years. Yes, going for 3 years. So negative 3 divided by 1 or 0.1. 0.1. Great. And we can proceed and utilize our calculators now. Utilize our calculators, or else you can use the table. If you don't have a calculator, you have a question? Already my R is 10%. Good question. My R is 10%, which is equivalent to 0.1. So 1 plus 0.1 gives me. Sorry for that. I decided to go very fast. That point. Very fast. So you can just get your calculator and give us the present value of that. So the present value of that. So how much? So if you don't have a calculator, you can utilize the past paper that I shared. It's a past paper with a table, a different table. You just need to go to where you have the 10%, then look at the number of years, where you have 3 years. Where they intersect, you read that here. So you look at that. Where they intersect, you read that figure. You don't have a calculator. So think what can you do? So if you go to the PVFA table, there are 2 tables there, PVFA and PVF. So go to table 2. Go to here, we have 10%, 3 years. Where they intersect with the 3 years, you need that figure. Exactly. So I have 70,000 times. Someone to read for me? How much? 2.4. 2.4? In 4 decimal places. 869. 869. Yeah, that will give us now the present value once you multiply. So you have read the table, or you have used the calculator. The calculator did the table and confirm. So that's giving you the same. Look at there are 2 tables. Table at Yapili, PVFA. The second table is the PVFA. Check that. Check that. And confirm whether it's giving you the same. Are you getting that? 2.4869? Great. You can use that table or you can use the calculator. But sometimes you find the table does not have some rates, right? So it is always good to know both rules. So can you give me the present value of that? Give me the present value of that. What happened?
I use this one.
You can give 2 decimal places or eliminate decimals.
174.08.
What?
174.08.
080.
Yes.
Great. That is very good. Thank you so much. 174,080. That will be the present value. That will be the present value of that. 080 or 08. 83. You round off, eh? It's a whole number. So 83.
Yes.
Okay. Maybe our setting, the setting of our calculators may be different, but we are close to that. Yes, we are close to that. Okay, 173, 174 point 174,083, 083, 083, 083, 083. 083. Illustration number 2. Illustration number 2. You have a question? Yes, please. It is one. Which one? Yes, it is 1.1. This is negative 3. We are together now?
Yes.
All right. Now, illustration number 2. Determine the present value and the net present value. Determine the present value. The present value. And the net present value equity of project M. Project M, whose cash flows are as follows. As follows. Cash flows are as follows. Rate of return of the project is 13%. The initial outlay, the initial outlay is 50,000. Initial outlay is 50,000. Initial outlay is 50,000. Yeah, initial outlay is 50,000. So you're required to determine the present value and the net present value of the project. So I think that's what you can do. You can do the first part, get the present value first. Do the first part. And the second part we can do together. So first thing, identify which type of customer goes. The second point is that you write down the formula, then you start plugging in the figures. So we're going to do it fast. Very fast. Our present value. As we move forward, we shall be improving on our speed and accuracy. Also, a factor that is needed for us to pass this paper, speed and accuracy. We usually say SA, that is a factor. It's above speed and accuracy. That is a factor that is needed or required for us to pass this. You can see people are getting something to do with 59. 59, others are getting different. I don't know why. Almost there. We're almost getting it.
Yeah. 20,000 bonds.
That was 20,000, not 200,000. You used 200. Simple that. How much are you getting before how much you have? We're getting different answers. People are getting 72. So let's do it, do this together. Let's do this together and see what we get. Let's do it together. So the first thing is to identify the type of particle that you're dealing with. And in our case here, consider you are having a regular or uniform particle of 20,000. So the second point is to just write the formula. Future value times 1 minus 1 plus r. This is negative n divided by root of that divided by r. And then I plug in the figure. My future value is 20,000 times 1 minus 1.13 is negative. Is it 4? Yes, because we have 4 years divided by 0.13. So if you try to look at this in the table, we don't have a table. So it is good to know how even to use the calculator. So how much did you get as the PV for 13% 4 years? Now the calculator should work. PV for hapo najua ndio probably what to be. First of all, do the numerator. Sasa weka equals. Have to divide. Answer divide by 0.1.
2.197.
2.97.
45.
4 days compression. 9745, right?
Yes.
Now give me the figure there. 20 times that. 20,000. You are getting 59. 48. 49.4. Right. Right. Yeah, that is it. Now, if you want to get the net present value, you take the present value minus the initial what? Investment, the initial output. That will give you the net present value, so that you're able to make an informed decision. So the present value will be 9489. So this is 50,000. So it will be 59,489. 4 minus 50,000. This is initial outlay or initial investment. So it will be 94 89.4. This is a positive NPV that indicates that project is profitable. If you get a negative NPV, the project is not profitable. The project is not profitable. So if you get a positive NPV, you say that the project is profitable and the investor can take that project. Investor can take that project. So it's good to note that sometimes you can get negative NPV that indicates that the project is not profitable. Now let's move to another question. Let's move to another question that will help us to understand the irregular. What we now irregular. Those special cash flow, and we're going to determine that. And we're going to determine the present present value. The first thing is to determine or to identify the types of cash flow that we have. So in our case here, what is the type of cash flow? Irregular cash flow. So to differentiate or to discount that, we use PV 12%. So for this, what you do, you just check for each year, the PV for each year. That is the difference now. Because we have different cash flows, we check the PV for each year. So PV for each year. So year one, what is the PV? PV for year one. Just use your calculator. You know the PV formula. But then you then give you the PV formula. 1 plus R. Not R. PV formula. I gave that. PV. Is 1 plus R raised to negative N. That. PV formula 1 plus R raised to negative N. So you just use that formula to get these figures here. So the 4 decimal places, give me the first one. 4 decimal places, give me the first one. 4 decimal places, give me the first one. 0 point something. This one is 0 point something. Or PV, get it at 0 point something. You can as well use the table. Look where you have 12%, check year one, where they intersect. That is the figure we want. And then you compare with your calculator. So the first one is 0 point. Yeah, it should be 0 point. 1.12 raised to negative 1. Yeah, 1. Yes?
12 or 1.
12%. 12. So it is 1 plus 0.1. It is 1.1
Yes.
raised to negative 1. So you go to year 2, negative 2 like that. That. So how much are we getting?
0.8929.
29. The second one I expect will be 0 point something.
0.2. 0.7972.
7972. The other one?
0.7118.
Second last.
0.6355.
And the last one? The last one.
0.5674.
Wow, that is very good. 0.5674. So those are great. You can compare what you have in the table. You can check your table in a particular name. One. Then we get the discounted cash flow. Discounted cash flow. Discounted cash flow. You get the discounted cash flow. This is the discounted cash flow. So you take the cash flow times the PV. Cash flow times the PV. That will give you the discounted cash flow. Get the present value, you do the summation of the part. What are you getting? So how much are we getting for the first year? The discounted cash flow for the first year, you got just take 70,000 and 3.8929. What are we getting for the first year? 62,503. Guys, you're getting the same? 62 or something? 62,503. It is 62,503. It is. So we get 62,503. So a whole number is okay. Just convert it, round it off to whole number. So year two, getting how much? Year two. 10? 5944. All right. Year three. 21,354. And year four.
1,775.
1,775. And last three.
3,000. 6,000.
6,000.
3,404.4.
404.4. So the total is our present value. The total. Total is of time. And this is total is good. This is total is good. Total will be that. The present value. The total will be the present value. The batch is
134.97.
134.
98.4.
980.4. Thank you so much. That is our present value of the types of cash. That is our answer. I want to give you one with really fast. Try to increase your speed a bit, a little bit. Just do that very fast before we move to the next part. Let's do that very fast. So let's see the speed that you have. Remember, speed and accuracy. So we say that it is a factor. It is a factor. is a factor that we consider for passing this. So we have 200,000 between 150,000 and 75,000. Let's say we'll be the first one to ring the bell. The first one to ring the bell. That is speed. That is a factor that everyone needs to have. Factor that everyone need ring the bell. Speed and accuracy is our motto. Our motto is speed and accuracy. One person done. What we shall compare for the speed that is achieved. Now we shall compare your accuracy. See whether you are following the two. Speed and accuracy. They are cousins. Speed and accuracy are cousins. So for cousins, don't talk right. Cousins don't talk. They are brothers and sisters. So even during exam, there are those students who finish within the first 1 hour. You wonder, what? Do I have the content? Where do they have the content? They start moving out. You should not panic. Just look at your watch and see that you have extra 2 hours and work on your speed and accuracy. And probably for them, speed is okay and accuracy is new. So, of course, yes, speed can be okay and accuracy is 0. People are getting 336, 647. You guys are great. Then, Kevin, what do you have? Kevin, you have 500,000. You have a different. You have 500,000. 500,000. Maybe maybe for this one, I don't expect to see. It's for this is low. You get Mahamud, where are you? Almost there, right? All right, right. In short, we can venture to another concept. Another concept that is highly examinable. Concept that is highly examinable. Concept that is highly examinable. If you like 2 minutes, not 2 minutes so much. It will be like 1 minute that you finish up. So we're looking at a certain concept here, which is highly examinable. Highly examinable. Therefore, we really need to understand. So let's look at the ranges. Fringes. So we want to determine the present value from the cash flow provided, the cash flow given, cash flow given. We got 339. 339 or 336. We got 336 in the previous. 336 times. Or 336. Okay. Check should be 336. 336 is 14. 7. 6, 7. Okay. Now, if you look at this question, which type of cash flows do we have? Which type of cash flow do we have? Irregular. I give you a second chance to state again. Irregular cash flow. Okay. Everybody is a different answer. Everybody is a different answer for you. So all of you are for irregular, right? Okay. 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 Look at our ears. Our ears consistency. We are having some range, right? So if I pick here 3, 4, 5, 6, and 7, then I'm saying that the cash flow is 3,000. 3,000. 5 plus. Which type of cash flow is that? You see, this is how examiner will hide something or another class. Right. So this type of cash flow, we have both regular and irregular. And therefore, if I need to get the present value for this, if I need to get the present value, simple, because I will use PVF or PVF related to 4%. So for any standalone cash flow here, we use that PVF or PVF. PVF and standalone. Year 1, 2. Shall we use PVF or PVF? Discount. PVF, right? It is PVF for any standalone cash flow. We shall use PVF. So can you give me the PVF for the first year? PVF for the first year. Just engage your calculator. For the first year.
0.8621.
8621. All right. Great. What about the second one?
0.7432.
7432. Thank you so much. Now, the challenge comes when you want to get the buffer for the range. But it is simple since you know that if I can get the buffer for all the 7 years, and then I subtract the 2, I'll remain with that range. You get that? You get the buffer for all the 7 years, and then you subtract the 2 years. You will remain with that the difference, which will be the buffer for the range. You get that? So if I want to get the buffer for year 3 to 7, it will be given by the buffer 7 years, and our n is 16, right? 16, no, n is 7. Our rate is 16% minus the PV for the 2. And therefore, we know that the PV. So give me the total. What will be the total? The total? 6053. Thank you so much. Now it is simple for us to get the PV for 7 years, 16%, which will be equal to 1 minus 1.16 raised to power negative 7 divided by 0.16 minus 1.6053. So how much is this for the first one?
4.03.
4.03.
86.
86 minus 1.605. You give me how much? How much shall we get?
2.433.
2.4330 for the space.
No, it doesn't matter. This one.
333. 333. That's so 2.43. That's the way we get the PV for the range. Give me the PV for the area. Area. For the area. How much?
0.3050.
0.350.
0.
50.
Yes.
Like that.
Yes.
0. Now, Yon, can you give me the PV for the range? Yeah, 914. 914. What about that one? What about that one? The 914. The 914. The 914. Right?
How can I use it?
No. If I want to get this PV, I must first of all get the PV for 14 years, right?
Yes.
And then I subtract all this that I made in that 914. All the total, right? Or else you can just pick this. This is for how many years? 7, right? This one. Then you add this for the 8 year. Subtract that one. Well, what you get? PV for 14 years, 16%. Okay. This is what we mean. So the first thing we need to get the PV for 14 years, 16% minus the PV farm that is from year 8, or PV farm plus PV from year 8 going up, right? Which will be the total of what we got for year 7. PV farm for year 7 is 4 points. 4 points, just take. PV farm for year 7, we had 4 point something. Yeah. 4 points. Give me the exact. Or else, can you add all this? Add all this. Add all this. In fact, the PV for year 7, it is this one plus the 2. Plus the 2. So add all this. Add all this. Yote ni ngapi? Hapa. Give me the total. Save us. Add all this. And if you want to remember the PV for year 7, you can take this from the 2. How much? How much?
4.3.
Aha.
886.
Hiyo unanipatia sasa ya gani?
Yes.
Yote.
Yes.
4.3.
886.
886. 886. Good. Now, let's get PV for 14 year 16%, which will be 1 minus 1.16 raised to negative 14 divided by 0.16. So you got how much? 467.5. Great. So to get the PV for the range 914, you take this one minus, so it will be 5.4675, 4.3886. So how much?
1.0789.
1.0789. 1.0789. That will be our before for that page. Before for that page. Then the final one, we have year 15 to infinite. How do we get PV for an infinite? PV for an infinite tunapata namna gani? Is given by 1 over R. 1 over R. 1 over R. So can you give me that? PV for an infinite is 1 over R. So give me that. How much?
6.25.
All right. So PV for infinite is equal to 1 over R, which is equal to 1 over 0.16. So it is 6.25, right? So if I want to get these PV for these range up to infinite, just pick what was there PV for 14 years, which is this 6.25 minus 5.4675. Utapata ngapi? How much shall we get? Is it 0 point something? 0 point. Okay. 0.725. Thank you so much. Thank you so much. Now the big deal is done. Big deal is done. The only problem arises getting this. Once you get that, it's possible for you now to get the discounted cash flow. Discounted. Get the discounted cash, you just take the cash flow and the PV this one. So give me the discounted cash flow for year 1 like that. Just follow this the rate, you just keep the cash flow times the PV like that. So the first one ni ngapi? Unapata ngapi? 6034.7. That is very good. The second one, 2000 times this. 1486.4.
Yes.
Thank you so much. And then we go to the range. Now we pick the cash flow at this 2.4333. 3,000 times this. 9299.9, right? Then we move to year 8. It is as simple as that. Year 8. 2100. Ah, it's okay then. Put a 0 there for consistency. Then we have year 9 to 14, 8,000 represent that, all of that batch. 86, 1.2%, and the last one don't tell me, it's going to just take 78, 25, right? 78, 25, 4, yeah. Then you add all these to get the total present value. Please add all of them to get the total present value. And all of them to get the total present value. That will be very okay. Very okay. Present value. Before getting something. Before getting something very good. That 377.2. That 377.2. That is similarity. See, so the similarity yako iko wapi? Yako umepita.
It's yeah.
370.2 similarity. This is very good. Kevin, that 377.2. So that is our total present value at 377. 377.2. And then the examiner can proceed and tell you that the initial outlay of this project, these are projects. The initial outlay of the project. The initial outlay of the project is 40,000 or was 40,000. Determine the net present value and hence advise the investor. This is where now you make the decision on whether the investor can undertake that project or not. Now, in this case, we need to get the NPV. Can you get the NPV for me? The formula is NPV is given by present value minus initial outlay. Yes, present value minus initial outlay. So in this case, I have the present value there and transfer here. That 377.2 minus 40,000. That is good. So give me the net present value, and this one help us to appraise the projects. So how much?
22.8.
A negative 6. 22.6. 0.8.
Yeah.
22.8. Now, as a financial management student or a financial analyst, an investor turns to you in these types of cash flow, ask you whether they should undertake the project. And you do your analysis and you find such an answer. What do you advise such an investor? They should not undertake the project. If they proceed and undertake the project, they are going to incur these are losses, right? So that is how we do the appraisal. Now, I want to give you a question from May 2018. May 2018, look that first paper, May 2018, question number 4. May 2018, question number 4. We want you to do that question very fast. And if CASNEP give you 36 minutes to finish a 20-mark question, what of 5-mark question? How many minutes should you take? Can you do that mathematics and then do that to finish that question? Side mathematics. So you don't have a question. Now, for what you do, yes. So meanwhile, you can use mind to look at it. So that you can do it very fast. You have just coming from quite a bit. All right. No, let's see how we can. Yeah, 40. If somebody is telling us how many minutes you should take to look at the number of given. You have already added yes. Have you seen the question or not yet? Just use mine as we organize it. Let's use mine. Lend him a piece of paper. This is something that we want to time ourselves. A piece of paper, just one. Here's a piece of paper. So let's use very few minutes, like 6 to 7. 6 to 7. If 20 marks question take 36 minutes, what about 5 marks? About 5 marks. About 5. About 5. Kama swali la max 20 tunachukua dakika 36. What about swali la max 5? Itachukua dakika kitu 7 hapo. 7. So I assume that all of us have started. So by 7:57 it should be done. Point 8 going on, you can take a picture of this question in your phone. Or you already are. They have already taken it. It's okay. By the way, your time will be affected. But as well, we can use these table, yes. We have a table, we can stick it is 10%. So our time is counting. Immediately we get to 57. Done. How 4 minutes? 4 minutes. Right. Okay. So,
I don't think we should.
You're done already. Haikuwa na issue hiyo. Haikuwa na issue. You got 42. So people are done. 30 people are getting a different answer. I don't know why. No.
I've already tried.
You have tried. Not yet. Not yet. What took too long? And we said hidden accuracy is the hidden accuracy is the key. We shall do it together. We shall do it together because time is up. Let's do it together and then we see what was expected of us. What was expected of us. Yeah, that is how it is tested. That is how the concept is tested. That is how the concept is tested. So, Mahmoud, how much did you get? 25. All right. So we have the year here, and we have the cash flow. So the year is 1 to 5, right? Yes. Then 6 to 10. And then 11 to 15. And the cash flow for this range? 5,000. 5,000. 9,000. 4,000. I don't need the total, whatever that they're giving me, I don't need. So I am going to use the FIFA to discount these.
Yes.
And the rate is 10%?
Yes.
Right. Now, if I want to get PVFA for 5 years, how do I do it? It is a direct one. It's 1 minus 1.1 raised to negative 5 divided by 0.1. Tumepata ngapi?
3.7908.
0.8. That is the direct one. So when it comes to this point, remember what we do. If I want to get PVFA for this range, 6 to 10, I must first of all get PVFA for 10 years, and then I less for 5 years. That difference. So let's get PVFA for 10 years. PVFA 10 years, 10% will be equal to 1 minus 1.1 raised to negative 10, divided by 0.1. Ingapi? 6.1446.
Yes.
And then I have PVFA for 5 years. So I just take 6.1446 minus 3.7908. Ingapi? 2.3538. 2.3538. We're doing well. Doing well. And the final one, I look at the PVFA for 15 years. 15 years, which is 1 minus 1.1 raised to negative 15 divided by 0.1. Ingapi? PVFA for 15 years. Somebody. 7.6061. So for me, it is easier because I know PVFA for 10 years is this one. So I just take this one, I minus this. Or else, you can add the two. Right? So I take 7.6061 minus 6.1446. Napata ngapi hapa? 1.46. 15. That is it. I can get my discounted cash flow by taking the cash flow times the PVFA. So give me the first one for the first range. 18, 924, 54. Okay. The other one? 21, 183. The last one? 5846. And then you add to get the total present value. Inga 45? 45, 982 points. 0.4. Ama haina point. Acha ikae hivyo. So that is it. That is it. So always be very keen as far as such a question is concerned. You are almost there. Almost there. I think the only problem was there. That one. Subtracting. All right, that is okay. Kama ni kwa mtihani kwa marks 5 ungepata kitu mbili. Right, we almost there. All right. So that is very good. That is very good. And that marks the end of our today's session till Friday. So, it's part to be today. Yes.